Hello everyone. In today's session, we will cover EC8751 Optical Communication, Unit 3rd, Optical Sources and Detectors, multiple choice question and answer for your upcoming examination. Let's begin the session. First question is, a perfect semiconductor crystal containing no impurities or lattice defects is called as. Here, correct answer is option A, intrinsic semiconductor. Okay. An intrinsic semiconductor is usually undoped. It's a pure semiconductor, right? The number of charge carriers is determined by the semiconductor material's properties and not by the impurities. Okay? So, a perfect semiconductor crystal containing no impurities or lattice defects is called as intrinsic semiconductor. Next question. The energy level occupation for a semiconductor in thermal equilibrium is described by the correct answer is option C, Fermi-Dirac distribution function. This is very important question. Just listen to me very carefully. For a semiconductor in the thermal equilibrium, the probability P of E that an electron gains sufficient thermal energy at an absolute temperature so as to occupy a particular energy label E is given by the Fermi-Dirac distribution function. Okay, and it's given by P of E is equal to 1 divided by in bracket 1 plus exponential exp in the bracket E minus EF divided by KT, where K is equal to Boltzmann constant, T is equal to absolute temperature and EF is equal to Fermi energy label. Okay, just learn this formula. This is very important and very important question also. Okay, next question. What is done to create an extrinsic semiconductor? Here correct answer is option B, doping the material with impurities. An intrinsic semiconductor is a pure semiconductor. As you know, an intrinsic semiconductor is obtained by doping the material with impurity atoms. These impurity atoms create either free electron or holes. Thus, extrinsic semiconductor is a doped semiconductor. Okay. So, doping the material with impurities is done to create an extrinsic type of semiconductor. Okay. Next question. The majority of the carriers in a p-type semiconductor are, correct answer is option A, holes. Because the impurities can be either donor impurities or acceptor impurities. Okay. Only two cases are there. Maybe donor impurities and maybe acceptor impurities. When acceptor impurities are added, the excited electrons are raised from the valence band to the acceptor impurity labels, leaving position charge carriers in the valence band. Thus, p-type semiconductor is formed in which majority of the carriers are positive, that is holes. Next question. Blank space is used when the optical emission results from the application of electric field. Here, correct answer is option C, electroluminance. Okay. Electroluminance is used when the optical emission result from the application of electric field. Because electroluminance is encouraged by selecting an appropriate semiconductor material. Direct band gap semiconductors are used for this purpose. In band-to-band recombination, the energy is released with the creation of photon, and this emission of light is known as electroluminance. So, electroluminance is used when the optical emissions result from the application of electric field. Okay. Next question. In the given equation, what does P stands for? And equation is P is equal to 2 pi hk. Correct answer here is option D, crystal momentum. Okay. Here P stands for crystal momentum. In the given equation is a relation of crystal momentum and wave vector. In this equation, P is crystal momentum, H is Planck's constant, and K is the wave vector, and P is the crystal momentum. Okay, and pi is standard value is 3.14. Okay, so P is equal to 2 pi hk. P is equal to 2 pi hk. This is the equation is a relation of crystal momentum and wave vector. Okay. Next question. The recombination in indirect band gap semiconductors is slow is true or false? Is true. Because in an indirect band gap semiconductor, the maximum and minimum energies occur at different values of crystal momentum. However, three-particle recombination process is far less probable than the two-particle process exhibited by direct band gap semiconductors. Hence, the recombination in an indirect band gap semiconductor is relatively slow. The statement, the recombination in indirect band gap semiconductors is slow, it's true. Okay. Next question. Which impurity is added to gallium phosphide to make it an efficient light emitter? Here correct answer is option C, nitrogen. An indirect band gap semiconductor may be made into an electroluminescent material by the addition of impurity centers, which will convert it into a direct band gap material. The introduction of nitrogen as an impurity into gallium phosphide makes it an effective emitter of light. Such conversion is only achieved in materials where the direct and indirect band gaps have a small energy difference. Okay. Next question. Population inversion is obtained at p-n junction by, correct answer is option D, heavy doping of both p-type and n-type material. Okay, because population inversion at p-n junction is obtained by heavy doping of both p-type and n-type material. Heavy p-type doping with acceptor impurities causes a lowering of the Fermi level between the filled and empty states into the valence band. Similarly, n-type doping causes Fermi level to enter the conduction band of the material. In this way, population inversion is obtained at a p-n junction by a heavy doping of both p-type and n-type material. Right? Next question. Which type of mechanical splicing exhibits the permanent bonding of prepared fiber ends with the rigid alignment of the tube? Here, correct answer is option A, snug tube splicing. Okay. Snug tube splicing type of mechanical splicing exhibits the permanent bonding of prepared fiber ends with the rigid alignments of the tube. Next question. Which among the following is regarded as a keyed bayonet connector along with its feasibility of easiest insertion and removal from the fiber optic cable? In this question, correct answer is option D, ST connectors. ST connectors is regarded as a keyed bayonet connector along with its feasibility of easiest insertion and removal from the fiber optic cable. Okay. Next question. The small section of fiber which is coupled to the optical source is known as fly lead as well as pigtail also. Here correct answer is option C, both A and B. Okay. Next question. A homojunction is an interface between two adjoining single crystal semiconductors with different band gap energies. This statement is true or false? This statement is false. Because the photoemissive properties of a single p-n junction fabricated from a single crystal semiconductor material are called as homojunction. A heterojunction is an interface between two single crystal semiconductors with different band gap energies. The devices which are fabricated with heterojunctions are said to have heterostructure. Okay, so the statement a homojunction is an interface between two adjoining single crystal semiconductors with different band gap energies is false. Next question. How many types of heterojunction are available? Correct answer is option A, 2. The first one is isotype. Isotype heterojunction are also called as NN or PP junction, and second one is N-isotype heterojunction, and it's also called as PN junction with large band gap energies. Okay. Next question, LED structure is, correct answer is option A, low. Okay. As you know, LED stands for light emitted diode, and LED structure is low because planar LEDs are fabricated using liquid or vapor phase epitaxial processes. Here, P-type is diffused into N-type substrate, which creates junction. Forward current flow through junction provides Lambertian spontaneous emission. Thus, device emits lights from all surfaces. However, a limited amount of light escapes the structure due to total internal reflection, thus providing low radiance. Okay. In this way, LED structure is low. Okay. Next question. In optical fiber communication, blank space measure type of LED structure are used. Here, correct answer is option C, 6. In optical fiber communications, 6 major types of LED structures are used. Okay. These are the surface emitter, second one edge emitter, third one the superluminescent, fourth one the resonant cavity LED, fifth one planar LEDs, and sixth and last one is dome LEDs. Okay. Next question. As compared to planar LEDs structure, dome LEDs have blank space, external power efficiency, blank space, effective emission area, blank space, radiance. This is frequently asked question, guys. Just listen to me very carefully. In domes LEDs, the diameter of dome is selected so as to maximum the internal emission reaching surface within critical angle of GAS. Okay. Thus, dome LEDs have high external power efficiency. Okay. The geometry of dome LEDs is such that dome is much larger than active recombination area. So it has greater emission area and reduced of radiance. In this way, correct answer is option B, higher, greater and reduced respectively. As compared to planar LED structure, dome LEDs have higher external power efficiency, greater effective emission area and reduced radiance. Okay. Next question. The techniques by Burroughs and Dawson in reference to homostructure device is to use an each bell in GAS structure. This statement is true or false? This statement is true, because Burroughs and Dawson provided a technique to restrict emission to a small active region within device, thus providing high radiance. Each bell in a GAS substrate is used to prevent heavy absorption of emitted region and physically accommodating the fiber. These structures provide low thermal impedance, allowing high current densities of high radiance. Okay. In this way, this statement is true. Next question. In surface emitter LEDs, more advantage can be obtained by using blank space. Correct answer here is option C, DH structures. DH structures provide high efficiency from electrical and optical confinement, because along with efficiency they provide less absorption of emitted radiation. Okay. Next question. Internal absorption in DH surface emitter Burroughs type LEDs is, correct answer is option D, very low, because the larger band gap, confining layers and the reflection coefficient at the back crystal space is high in DH surface emitter Burroughs type LEDs. This provides good forward radiance, and thus these structures LEDs have very less internal absorption. Okay. Next question. DH surface emitter generally give, correct answer is option A, more coupled optical power, because the optical power coupled into a fiber depends on distance, alignment between emission area and fiber, SLED emission pattern, and medium between emitting area and fiber. All these parameters, if considered, reduces refractive index mismatch and increases external power efficiency, thus providing more coupled optical power. Okay. DS surface emitted generally give more coupled optical power. Okay. Next question. In a multi-mode fiber, much of light coupled in the fiber from an LED is, correct answer is option C, lost, because optical power from an incoherent source is initially coupled into large angle rays falling within acceptance angle of fiber but have more energy than meridional rays. Energy from these rays goes into the cladding and thus may be lost. Okay. Next question. Mesa structured SLEDs are used. Correct answer here is option C, to reduce current spreading. Okay. The planar structure of Burroughs type LEDs allows lateral current spreading, especially for contact diameters less than 25 micrometer. This results in reduced current density and effective emission area greater than contact area. This technique to reduce current spreading in very small devices is Mesa structured SLEDs. Okay. In this way, Mesa structured SLEDs are used to reduce current spreading. Okay. Next question. The in GAASP is emitting LEDs are realized in terms of restricted R blank space. Here correct answer is option A, length strip geometry. The short stripped structure of these LEDs around 100 micrometer improves the external efficiency of LEDs by reducing internal absorption of carriers. These are also called truncated strip ELEDs. Okay. Next question. The active layer of ELED is heavily doped with, correct answer is option A, Zn. Zn doping reduces the minority carrier lifetime. Thus, this improves the device modulation bandwidth. Hence, active layer is doped in Zn in ELEDs. Okay. Next question. A device which converts electrical energy in the form of a current into optical energy is called as, correct answer is option A, optical source. Okay. An optical source is an active component in an optical fiber communication system. It converts electrical energy into optical energy and allows the light output to be efficiently coupled into the optical fiber. Okay. Next question. How many types of sources of optical light are available? Correct answer is option C, 3. 3 main types of optical light sources are available. These are wideband sources. Second one, monochromatic incoherent sources. Okay. And ideally the optical sources should be linear. In this way, correct answer is option C, 3. Next question. The radiation emission process means emission of a proton at frequency can occur in blank space ways. Here correct answer is option A, 2. The emission process can occur in 2 ways. First is by spontaneous emission, in which the atom returns to the lower energy state in a random manner. Second is by stimulated emission, where the energy of a photon is equal to the energy difference and it interacts with the atom in the upper state, causing it to return to the lower state along with the creation of a new photon. Okay. Next question. Which process gives the laser its spatial properties as an optical source? Here correct answer is option D, stimulated emission. In stimulated emission, the photon produced is of the same energy to the one which caused it. Hence, the light associated with stimulated photon is in phase and has same polarization. Therefore, in constant to spontaneous emission, coherent radiation is obtained. The coherent radiation phenomena is in laser provides amplification, thereby making laser a better optical source than LED. Okay. Next question. Often blank space pulse shape is obtained from APD. Here correct answer is option C, asymmetric. Often asymmetric pulse shape is obtained from APD. Okay. Asymmetric pulse shape is acquired from APD. This is due to relatively fast rise time as electrons are collected and fall time dictated by transmit time of holes. Okay. Next question. Fall times of 1 nanosecond or more are common. Is true or false? Is true. Option B is correct. Because the use of suitable materials or structures give rise times between 150 and 20 ps. Thus, fall times of 1 nanosecond or more are common, which in turn limits the overall response of device. Okay. Next question. At low gain, the transmit time and RC effects blank space. Here, correct answer is option C, dominate. Okay. Low gain causes the dominance of transit time and RC effects. This gives a definitive response time and thus device obtains constant bandwidth. Okay. Next question. At high gain, avalanche build-up time blank space. Correct answer is option C, dominates. Okay. High gain causes avalanche build-up time to dominate. Thus, the bandwidth of device decreases as increase in gain. Next question. Blank space has more sophisticated structure than PIN photodiode. Here, correct answer is option A, avalanche photodiode. Avalanche photodiode has more sophisticated structure than PIN photodiode because avalanche photodiode is second major type of detector in optical communications. This diode is more sophisticated so as to create a much higher electric field region. Next question. The phenomena leading to avalanche breakdown in reverse biased diode is known as, correct answer is option C, impact ionization. In depletion region, almost all photons are absorbed and carrier pairs are generated. So there comes a high field region where carriers acquire energy to excite new carrier pairs. This is impact ionization. Okay. Next question. The digital transmission on implementation of polarization modulation, which involves polarization characteristics of the transmitted optical signal, is known as, correct answer is option D, polarization shift keying. Okay. In depletion region, almost all photons are absorbed and carrier pairs are generated. So there comes a high field region where carriers acquire energy to excite new carrier pairs. This is impact ionization. Okay. Next question. The digital transmission on implementation of polarization modulation, which involves polarization characteristics of the transmitted optical signal, is known as, correct answer is option D, polarization shift keying. Okay. Polarization shift keying is abbreviated as pole SK, and pole SK requires additional receiver complexity than other modulation formats. Okay. Next question. 8-label FSK and binary PSK yields an equivalent sensitivity. This statement is true or false? This statement is true. Option B is correct. Binary PSK and 8-label FSK provides an equivalent sensitivity. The main drawback of 8-label FSK is that it yields an equivalent sensitivity to binary PSK at the expense of a greater receiver bandwidth requirement. Okay. Next question. External modulation for blank space modulation format allows the most sensitive coherent detection mechanism. Correct answer is option C, PSK. External modulation for PSK is usually straightforward. It's therefore utilized to provide the modulation format which allows the most sensitive coherent detection mechanism. Okay. Next question. Can potentially provide spectral conversion through the use of multi-label signaling. In this question, correct answer is option A, M-array PSK. In M-array schemes, the spectral efficiency is increased by the factor log 2m. Okay, this is purely for M-label schemes which can provide multi-label signaling patterns. Next question offers the potential for improving the coherent optical receiver sensitivity by increasing the choice of signaling frequencies. Here correct answer is option A, MFSK. Okay. Multi-label FSK includes 4-label or 8-label FSK. It improves the receiver sensitivity by reducing the deviation and increasing the uses of signaling frequencies. Okay. Next question, blank space doesn't require an external modulator. Correct answer is option A, FSK. FSK doesn't require an external modulator because FSK involves the frequency deviation property of the directly modulated semiconductor laser used in wideband systems. Unlike ASK, it doesn't require an external modulator, which in turn avoids the wastage of transmitted power. Okay. Okay guys, now let's wind up the session. If you liked the video, please hit the like button and make sure to subscribe to my channel for more updates. Please share this video with your friends and wish you very all the best for examination. Thank you.